In this lesson, we are going to learn what the Pythagorean Theorem is and how to apply it. To begin, we first need to talk about some vocabulary. The first vocab word is a right triangle. A right triangle is a triangle with one right angle. In a right triangle, to show that it is a right triangle, we must mark it. So in this particular triangle, I'm going to mark my right angle with the box. The second vocab word is the leg of a triangle, a right triangle. The sides are adjacent to the right angle. So in this picture, my leg is the one that's going vertically and horizontally. Those are the two lengths that create the 90-degree angle, my right angle. Then you have the hypotenuse. The hypotenuse is always opposite of the right angle. So in this picture, my hypotenuse would be this side. The hypotenuse is always, note to self, the longest side of a right triangle. And then we have something called the Pythagorean triple. A Pythagorean triple are three integers, so integers meaning 1, 2, 3, or -1, -2, -3, that satisfy the equation a squared plus b squared equals c squared. Now, Pythagorean triples, though, will always be positive because we will not be having any negative blanks. Now, we are going to then use this theorem throughout the lesson in the remaining part of the chapter. So this is something you should highlight in your notes. So to begin, Theorem 7.1, Pythagorean Theorem. It states that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So what that means is if I have a right triangle, so I'm going to mark my right angle, with leg lengths, we'll call them A and B, and we'll call the hypotenuse length C. The theorem says that if I take the legs squared, A squared, and the sum means to add, plus B squared, it will equal then my hypotenuse, my C length squared. Let's put this into practice in the next example. In example 1, it says find the length of the hypotenuse, so there's the question, of a right triangle with leg lengths of 9 and 12. So I'm going to mark my label, so I have my right angle, I have 9 inches, and I have 12 inches. What's missing is the hypotenuse, and I'm going to label that value length C. So setting up my Pythagorean theorem, I have 9 squared plus 12 squared equals C squared. If I do the math, that's 81 plus 144, and that totals 225. Now, to get the C squared, just C, I need to now take the square root of both sides, because the square root and the square will cancel, leaving me the value of C, the square of 225 is 15. So my hypotenuse is 15 inches. And I found that by using the Pythagorean theorem. Problem number 2, you have a 25-foot ladder. So in this particular picture here, this ladder leaning up against the house is 25 feet. And it says that the 25-foot ladder must be 6 feet from the base of the house. So my base from the house to the end of the ladder, this distance is 6 feet. How far up the side of the house will the ladder reach? That's my question. Well, we can assume that the house is perpendicular to the ground. The question is asking for then this distance here. So I'm going to call it length A. So I'm trying to find length A, which is a leg length. That's the distance how high up on the house the ladder can reach. Setting up my Pythagorean theorem, I'll have A squared plus 6 squared equals 25 squared. That gives me then 36, and 25 squared will give me a total of 625. If I minus the 36 over, I have A squared equals 589. And then once again, I need to take the square root of both sides, and I get the length A is the square root of 589, which is approximately 24.27, and that's in feet. So that is how far up on the house the ladder can reach. Looking at problem number 3, it says find the area of the triangle. So I need to first write down what that formula is. The area of a triangle is 1/2 times base times height. Now, in this particular triangle, the height of my triangle is the altitude. So in this triangle, I can see that this altitude right here, it's going from the vertex to the base. That's my height. I need to find. Now, also I need to note that this triangle is marked as an isosceles triangle. Since it's an isosceles triangle, that means the height bisects the base. So the length of 4 is also here as well, giving me a total base length then of 8. When I go back to my area formula, I can evaluate the base, plug in the value of 8, but I still need to find that height. So to do so, I'm looking at a right triangle. Now in that right triangle, I have the hypotenuse across from the right angle. So the 12, that's my hypotenuse. If I set up my equation, I'm going to have 4 squared plus h squared equals 12 squared. When I go to solve for h, I'm going to subtract 16 over to 144. That gives me h squared, which equals 128. Take the square root of both sides, and I get h is approximately 11.31 centimeters. Now I can go back and plug that into my equation. And if I calculate this on my calculator, I get the area to be half of 8, which is 4, times that by 11.31, I get 45.25 centimeters squared. And there's the area of my triangle. Now, the next thing is we need to talk about Pythagorean triples in a little bit more detail. Pythagorean triples will help you solve and process through problems faster and easier if you know your 5 most common Pythagorean triples. Right? Now, those 5 most common Pythagorean triples are listed here. What that means is that if I look at the numbers 3, 4, and 5, if I take 3 squared plus 4 squared, that equals 5 squared. If I take 5 squared plus 12 squared, that equals 13 squared. I know that that largest value will always be the hypotenuse because the hypotenuse is the longest side of the right triangle. Now, if I take these most common Pythagorean triples and multiply them by 2, I get another set of Pythagorean triples. So once again, 6 squared plus 8 squared, that will equal 10 squared, and so forth. Then I times 3, 4, and 5 by 3. Then I times 3, 4, and 5 by 10. And that gives me a list of Pythagorean triples. All of these triples do satisfy the Pythagorean theorem. Let's put these into practice. So in example 4, it says find the missing right triangle length. All right? Now, that missing length could be a leg length or it could be the hypotenuse. In the very first example, A here, I have a leg of 300 and 160. Now, I don't see 300 or 160 in my list of Pythagorean triples, but if I divide both of these by 10, I get 30 and 16. So I'm going to look for a list that has 30 and 16 in it, and I'm going to be looking for that missing hypotenuse length. Going back to my list, I can see here that I have 16 and 30. That missing hypotenuse length then is 34. Now, remember, in the beginning of the problem, we divided everything by 10. So I need to take 34 and times that by 10, and that gives me 340. So there is my missing hypotenuse length. Now, worst case scenario. If you're not recognizing something as being a Pythagorean triple, you can always set up the Pythagorean theorem. I could take my leg squared plus the second leg squared, and that's going to equal my hypotenuse squared. So if I do the math here, this combines to be a total of 1,115,600, and that equals, we'll use c squared. If I take the square root of both sides, then I get the length to be 340. Looking at part B, I have a leg length of 3.5 and a hypotenuse of 12.5. Once again, these are not integers, so they're not a Pythagorean triple, but I can multiply them by something to see if they could be a Pythagorean triple. In this case, I'm going to multiply both by 2. That's 7. 12.5 times 2, that's 25. Looking back at my Pythagorean triples, 7 and 25 are what's in my list. Well, here's a leg length of 7. Here's a hypotenuse of 25. The missing leg length then is 24. So I have 7, the missing length, and 25. That missing length was 24. Now again, I did multiply everything by 2. So I'm going to divide by 2 to find that length. Divide by 2, that gives me the 3.5 again. Divide this by 2, that gives me the 12. And divide by 2, that gives me the 12.5 again. So my missing leg length is 12. For problem number 5, it says find the find the value. So I'm going to set up then Pythagorean theorem because I can see that I have a right triangle. My hypotenuse is always across from the right triangle, so this is my hypotenuse. If I set up the Pythagorean theorem, I have my first leg squared plus the second leg squared equals my hypotenuse squared. That gives me x squared plus, now the square root and square cancel, that's 7. The square root and square cancel, that's 19. If I minus the 7 over, I get x squared equals 12. And it says in the directions, it says properly simplify your radicals. So when I go to take the square root of 12, the square root of 12, it's not a perfect square. So I can break it up. I can say that's the square root of 4 times the square root of 3, which then simplifies to 2 square root 3. If you actually calculate the square root of 12 on the calculator, the decimal would be approximately 3.46, which is what 2 square root 3 is, 3.46. But the directions say they want a reduced radical. For part B, I can see that I have a right triangle again, and I can see that it's also an isosceles right triangle, and I have my hypotenuse as 8 squared root 2. So when I set up my equation, I'll have a squared plus b squared, so that's x squared plus x squared, equals 8 squared root 2 squared. Well, x squared plus x squared, that's 2x squared. And 8 squared root 2 squared, well, that's just the same thing as 8 times 8 times square root 2 times square root 2. That gives me 64. Square root 2 times square root 2 is 2, which gives me a total of 128. Solving for x now, I'm going to divide by the 2. So I get x squared equals 64. Then take the square root of both sides. And I get then x equals the length of 8. So for this last problem here, we are going to be able to find the area of the figure. But in this case, I don't have just a triangle or just a rectangle. What I can do, though, with this figure is I can cut up into 2 pieces. I can cut up into a rectangle with 4 right angles, and then I also then have a right triangle. Now, some properties of the rectangle. We know rectangles, the opposite sides are congruent, so this is 11 inches. And then this would give me 14 inches. And in the triangle, since this entire length is 20, I know 20 minus the 11 gives me a 9-inch base. So to start off with, I can find the area of that rectangle. And the area of a rectangle we know is length times width. So in this particular example, the area of my rectangle is 11 times 14. And then that gives me then a total of 154. Now the area of my triangle, that was what we just talked about in the previous example, the area of my triangle is 1/2 times base times height. So in this particular example, that's 1/2 times my base of 9 times my height of 14. And that gives me a grand total of 63 inches squared. So my total area of my figure is going to be the rectangle plus the triangle. So that gives me 154 plus 63, which is a grand total then of 217 inches squared.